Hello students, in this video we are going to learn about the basics of trigonometry. For class 10 Cbse maths, so this is the 8th chapter and you are introduced to this new concept of trigonometry in this year only. So we'll just learn about the basic concepts related to this trigonometry in this video. What is this trigonometry all about? So tri means what? We all know what is tri. Tri means what? 3. And the next is gon. Gon means sides. Okay. So this is all from Greek words. Okay. This is all from the Greek words. So trigon means what? 3 sides. And metri, that means a measure. That means a measure. It means the measure of 3 sides of a right angle triangle. Here we are always using a right angle triangle here. Okay. So why do we use this? We need, if we are given just one data and just one value, okay, it will be easy to find out the other 2 sides. For example, if we have to measure the height of a tower, okay, and you are going to stand at this place. So this distance we can very easily calculate, and also we can measure the angle. Okay, however big it may be, the angle can be easily measured. So by just knowing one angle, and that angle we are representing it as theta. This is represented as theta, and this is one distance. Okay, so if you are able to know one distance and one angle, we can very easily measure the other 2 distances. That means we can very easily measure even the height of the tower or any height. Okay, we can measure the height of the mountains also. This was used in earlier days to measure even the height of the pyramids also. Okay, so because you will have pyramids, and then with this they will be able to measure the heights of the pyramids also. Okay, so this is the concept behind, like how it all came in. We have different sides. Okay, how do we name these sides? So now let's see this. I told you this is the angle. This is the angle. We know for a right angle triangle, if you have a right angle triangle, using the Pythagoras theorem, if you need to find out one side, you need to know 2 sides at least. When we don't know the value of 2 sides, but we know the value of one side and an angle, these trigonometry ratios will come to our help. Okay, so here you can see that, so in this right angle triangle, you can have an angle either here or here, because this one we know it is going to be a right angle. Okay, if this is going to be here, we all know this is the longer side. This is the longer side. This is the base of the triangle, and this you call it as the altitude. You can call it as the altitude, or you can call it as the height of the triangle. Okay, so this is the base and this is the height. So if you are going to find the area of the triangle, you will write half into base into height. So this is the base, this is the height, this is the longer side. Okay, but here this longer side, we are naming this as the hypotenuse always. Irrespective of where we have the angle, this side, that is the longer side, is always named as the hypotenuse. Okay, so if we have the angle here, we'll have to name 2 more sides. One is called the adjacent side and another one is called as the opposite side. So what will be opposite side to this angle? We know this will be the opposite. This will be the opposite. So what will be adjacent? Automatically this side will be called as the adjacent. So likewise, if you have the theta here, you can say that this will be called as the hypotenuse and this side will be called as the opposite side, and this one will be called as the adjacent side. Okay, so this is all about your understanding of the sides of the right angle triangle while using trigonometry. Now we are going to learn something called trigonometric ratios. We are going to learn something called trigonometric ratios. So to find out these trigonometric ratios, we have different trigonometric identities here. Okay, so these are sine. So you can name this as, it is not sin actually, it is actually sine, cosine, tangent, cosecant, secant and cot. Okay, sine, cosine, tangent, cosecant, secant and cot. So this sine we are calling it to be only sin, cosine we will call it as cos, tangent as tan, cosecant as only cosec, secant only sec, and this is cotangent, we will call it as cot. So all these have some ratios which we need to remember. So to remember that, we are going to see this concept so, ka, tova. So, ka, tova. So what is so? See, this so, ka and tova, this s, c and t represents sine, cos and tan. Sine, cos and tan. So for sine, the formula is going to be your, along with s, what do you have? So s, o, h. So what is o? Opposite side. What is h? Hypotenuse. See here, the value of sine theta is what? Opposite by hypotenuse. Similar for cos. So for cos you have adjacent by hypotenuse, and for tan you have opposite by adjacent. That is your so, ka, tova. And remember, these two are reciprocal to each other. Cosecant theta is equal to the reciprocal of sine. You can see here. Likewise, secant is the reciprocal of cos and cot is the reciprocal of tan. So if you are familiar with this, you can very easily solve the questions which are given in exercise 8.1. I am talking about this for the class 10 Cbse children. So if these values are known, you can very easily approach these concepts to a certain extent. Okay, now we are going to learn the next thing called trigonometric ratios table. So it is a table of trigonometric ratios for some specific angles. For some specific angles we are given these values. Okay, so you should be able to write this table very easily without forgetting. I'll tell you an easy way to remember this table. You just need to remember the first line alone. So only this you need to remember. So what is there? 0, 1 by 2, 1 by root 2, so root 3 by 2 and 1. Remember, the first and the last doesn't have any denominator, or you can say it is 0 by 1 or 1 by 1, then also the meaning will remain the same. So in between you can see you have 2, 2, 2, but here alone you have root 2. Okay, 2, root 2 and 2. So 2 and 2, so 1 and 1, here 2 and 2, in between root 2. Okay, and for the numerator if you see, only above this 2 you have root 3. Only above this 2 you have the value of root 3, otherwise you have 1 here except the first value. Or you can just read it by practicing to tell this again and again. Like you can keep on repeatedly telling 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Even if you are going to remember it that way, it is going to be very easy for you. You will not be able to forget. So only this if you remember, the others are going to be very easy. See, for sine and cos, whatever value went from left to right will come from right to left for cos. See here, your 1 is here. Okay, your 1 is going to be here, and your root 3 by 2 has come here. Okay, and your 1 by 2 is here. See, and your 1 by root 2 is here. 1 by 2 and then 0. Okay, So for sine and cos, you're just going to write whatever you wrote from left to right, you are going to write from right to left. Right to left of sine theta. Okay. So for cos theta, it is going to be the right to left of sine theta. The next one is tan theta. What is the formula for tan theta which we learned now? Tan theta is equal to what? SOHCA TOA. So TOA. What is it? Opposite by adjacent. We already know. So SOH is what? Sine. So sine theta is what? SOH. So it is going to be opposite by hypotenuse. Likewise, your cos theta is what? SOHCA. So it is going to be adjacent by hypotenuse. So your tan theta, you can see that if you divide sine by cos, you will get tan theta. See here, you have opposite by hypotenuse, adjacent by hypotenuse. So if you are going to divide sine by cos, the hypotenuse will get cancelled, you will get opposite by adjacent. So your tan theta is nothing but sine by cos. Okay, so you can say that your tan theta is nothing but sine by cos. So you are going to use this exactly in the same thing. Okay, so if this is going to be 0, this is 1. What will be 0 by 1? 0. So here you have 1 by 2 and 1 by root 3 by 2. So you will get 1 by root 3 because 2 and 2 will get cancelled. So you'll end up with 1 by root 3. Similarly, see, you have the same value, so you have 1. See here, 2 and 2 will get cancelled. So it will be root 3 by 1 or root 3. See the last one. Last one is what? 1 by 0. So what is 1 by 0? It is going to be not defined, or you can say it is going to be infinity. So now tan theta is also known. Tan theta is what? Sin theta by cos theta. What is the formula for cosecant theta which we learnt? 1 by sin theta. So take the reciprocal of this. So you have 0. So what will be 1 by 0? Not defined or infinity. You have 1 by 2. What is the reciprocal? 2. 1 by root 2. The reciprocal is what? Root 2. For root 3 by 2, it will be 2 by root 3. And for 1, it will be 1. Next one is secant theta. What is secant theta? Secant theta is the reciprocal of cos theta. You can also do by that way. But it is easier as you did for sine and cos. You can do for cosecant and secant. So whatever you wrote from left to right for cosecant, you are going to write from right to left for secant. So 1, 2 by root 3, root 2, 2 and not defined. Okay, so this makes our job easier. And the last one is what? Cot theta. So what is cot theta? So cot theta is nothing but your reciprocal of tan theta. Cot theta is nothing but the reciprocal of tan theta. You can either write it by doing 1 by tan theta, or you can divide cosecant theta by secant theta. But this is better because doing the reciprocal will make the job easier. So when you have 0, you're going to make it not defined. So 1 by root 3, you will get root 3. For 1, the reciprocal is 1. So for root 3, it will be 1 by root 3. And for not defined, it will be 0. Because what is not defined? Not defined is going to be 1 by 0. What will be the reciprocal of 1 by 0? It will be 0. So please be careful with this sound. Many will tend to confuse with this. Okay. So if you know these values in your Cbse class and textbook, solving the sums in exercise 8.2 will be very easy, because you're just going to substitute these values as per the requirement. Okay, as and how you need, you are going to substitute. So in that way it will be easy for you. Next one, the final thing which we have to see is going to be the trigonometric identities. So in between you have a concept called complementary angles, which is deleted for the children in 2022-23 batch. Okay. So now we'll get into the trigonometric identities. So what are these trigonometric identities? We will have to remember these three formula. So cos square A plus sin square A is 1. Okay. So if you are going to substitute with all these opposite by adjacent, adjacent by hypotenuse and all that, you will finally end up getting this value 1 only. So that is how they have derived it. If you want to really go through the derivation, it is there in your textbook in page number 190, which is not actually required, but I will make you remember these trigonometric identities which are given in the textbook in an easier way, so that you will never forget it. Okay, so we will get into the trigonometric identities now. So remember in this way. So the first one, how I am going to write is sin square theta plus cos square theta equal to 1. Okay, so now you have cos square. So this one alone you will very easily remember. Okay, the next two also, in this way you remember, you have 1, but in between you put the minus symbol. So since you had C here, you will have to put C in both the places. Okay, so now what you have here is that you are going to write for cos, write COS. So what you have apart from cos related to this, it will be cosecant square theta. And what is the other trigonometric ratio in C? You have cos, cosecant and then cot square theta. Is it easy now? Next one. So you have cot here, you have cosecant here. What is the ratio related to cosecant? Can I say it is going to be secant square theta? Likewise related to cot is going to be what? Tan square theta equal to 1. If you are going to remember it in this way, you will never forget. Remember, you are writing first sin cos is your order. So sin cos is your order. Next one, up there you are going to write cos and then you are going to make it as cosecant and cot. Okay. The next one, from cosecant you are going to write secant. From cot you are going to write tan. Remember, for the first one you have plus, for the next two you have minus. For everything the right hand side is going to be 1. In this way, if you are going to remember, the trigonometric identities are going to be really easy. So what is this and this? See, sin square plus cos square is cos square plus sin square. It is the same only. So nothing wrong. Likewise, see 1 plus tan square A equal to secant square. Look at this. If I am going to take secant square A alone, I will have to take this to the other side, right? So what will happen to secant square theta? I can say it is going to be 1 plus tan square theta. So instead of theta, they have given it as A. It depends on whichever alphabet it is going to represent. Likewise, from this you can write cosecant square theta is equal to 1 plus cot square theta. So these trigonometric identities are related to the exercise 8.4. Okay. So in this, you should be able to find out which identity to be applied. Okay, so if you are able to do that, solving the problems in exercise 8.4 will be very easy. So I will also solve the problems given in exercise 8.4 one by one, so that you will be able to find out the difference between how to use trigonometric identities and in what way. So when you are using trigonometric identities, you will not only use this, but you will also use the above said ratios, the basic ratios also you will be using. Okay, so only then you will be able to solve these questions. Okay, so I hope you were able to understand this. So first one, trigonometric ratios, sin, cos, tan, cosecant, secant and cot. So remember this, so cot over opposite by hypotenuse, adjacent by hypotenuse, opposite by adjacent. So in this way, your cosecant is the reciprocal of sin, secant for cos and cot for tan. Likewise, the table, as I told you, slowly you have to learn left to right, right to left. For tan it is sin by cos, for cosecant it is 1 by sin, and for secant it is going to be the right to left of cosecant, and for cot it is going to be 1 by tan. So finally we did with the trigonometric identities. Just remember this, see if this is going to be easy for you. If this is easy, it would be better. Okay, Hope you understood, children. See you again in another video with probably with these example exercise 8.4 questions. Thank you, children.